Welcome to Grade 10 ICT video tutorials. Today we are going to study, in fact we are going to start the third unit of Grade 10 ICT. Remember, so far we have finished the first two units of Grade 10. The first unit is Fundamentals of ICT. The second unit is Fundamentals of a Computer System. So both of them have already been finished. As we know, both these two units are very important for the examinations. At the same time, both of them are very important for each and every individual student for managing the activities, day-to-day life activities. Whenever you do things, you have to use ICT, it's inevitable. So both these two purposes, for examination purpose, at the same time for managing and performing your day-to-day life, remember, you have to be very good with the first two units. But the third unit which we are going to start today is something different than the first two units, because in the first two units we studied the stuff related to theory and everything. So even some of you might have faced some problems in memorizing because they are related to the basic things and current affairs and everything. In fact, they are related to theory. But the unit which has to be started is related to numbers, in fact mathematics. So hope this unit is going to be an easy one. At the same time, you don't need to memorize anything in this unit. So that may be one of the things that you have to remember at the beginning. So straight away I step into the unit. So this unit can be written in different names. Some of the people can write this as number representations in computers. Some people may take this as number related stuffs. Some of them can write this as number systems. So names some are not matters, right? You may have any names for your title, but the facts are important. That's the one which I always mention in the class, right? So straight away I write the unit. So this is unit 3, Grade 10 ICT unit 3, data representations in computers. So here we have to take how the data are represented in a computer, how computer understands the data, and the numbers which we use in our day-to-day life. So we have to study so many things regarding the numbers, even though the title seems to be a little different than what I have introduced. But remember, this is all about numbers. So before we start the things, I must mention one thing, or I must explain something. See, now in our day-to-day life, we use numbers for various purposes. Even here also in the class, I can say that we have 65 students in the class. Look at that particular data, 65. What it is? It is a number. So when you go to a shop and you may ask the shopkeeper to give 500 grams sugar, 5 pence, 1 liter water. So 1 liter, that 1, 500, that 500, and 5 pen, that 5, all of them are numbers. So in our day-to-day life, the numbers are inevitable. Every day you work with numbers in different purposes. But we have to note one thing. 65 students here, 500 gram sugar, 500, 5 pen, that 5, that particular 1 liter, all these numbers are formed by using 0 to 9. So look at that 500. So that 500 is formed using 0 to 9. So I can say 65. This 65, 65. Look at the range. So those two digits, 65, should form this range. So the numbers which we are dealing in our day-to-day life should use 0 to 9 digits. But there may be some other numbers, in fact we can call them as number system, other number system which may use different ranges. Here we use 0 to 9 digits for performing or for making numbers. But at the same time, there are different numbers used for different purpose. So straight away I can introduce them. Here in this unit, we have to learn or we have to introduce 4 different numbers. So 4 different number systems. So better to name them first. The first one, that is the one which we use always, is called, look at them, 0 to 9. We use 10 various digits. So this is called decimal number. It's decimal number. Apart from this decimal number, there may be other number systems. So here in this unit, we have to introduce other three number systems. So the second one should be binary number system. I will explain the feature and everything later. Better to introduce them first. Binary number system. Then the third one is called octal number system. Finally, we have hexadecimal number system. So these are the 4 different types of numbers or number systems included in this unit. So we need to understand the features, the characteristics of each and every number systems in this unit. So better I can introduce them in a small chart. Right, for introducing them, I try to put a small chart, then only you can easily understand. So better take the first column as number systems or names of the number systems. This is my first column. Here I have to list the names of those 4 number systems which I have already mentioned, right? So okay, straight away I can put them. So decimal number system, binary number system, octal number system, and hexadecimal number system. These are the 4 number systems. In the second column, we will show the digits included in every number systems. So better I write it as short digits used. Digits used. I will explain the others later. Then in the next column should be the total number of digits used in every number system. So total digits The next column would be the base value. Every number system has its base, so better write the base first. I will explain everything later. Finally, better to show some examples. So straight away we take the decimal number. We already discussed about decimal number system. I told you a decimal number system uses 0 to 9 digits. So 0, 1, 2, 3 up to 9. So I can show them as 0-9. So I can show that range, not all the numbers. Hope you can understand. So now look at the third column, total digits. So how many digits are used? Let's count them 0 to 9, 10 digits. So in decimal number system, we have 10 digits. As I told you earlier, every number system has a base value. So look here, the base value for each and every number system should be same as the total digits used in every number system. For example, look at the decimal number system. It has 10 digits, total digits are 10. So it must be, the base must be 10. The base is always equal to the total number of digits used in every number system. Even for binary number system, the base should be equal to total digits. We will discuss later. Example, I can say 150. Look at the 3 digits used, 1, 5, 0. Look at them, 1 is in the range, 5 is in the range, and even 0 also in the range. So it is a valid number, it's a correct number in decimal number system. But I must tell you one thing here. For every number system, you must mention the base of the particular number system. For example, 150. So 150 is a decimal number system. So I must show the base in number or in words as base here. Something like this. Even I can write TEN, 10. So, or number 10. So this is important for each and every number system here. But you all have experience, we all work with numbers. None of us put this base 10 with numbers. Even I never say that this class has 65 base 10 students. You can't ask the shopkeeper to give 500 base 10 sugar or 5 base 10 pence. You can't, the shopkeeper can't ask you to give 50 base 10 rupees. In fact, that is the way, right? We have to follow that, but none of us follows. The reason is very simple, because always we are dealing with decimal numbers. All the time we use decimal numbers. So imagine if the base is must, you have to write that base all the time. So whenever you write number, you have to write the number with 10, with base. That is very hard. That kills some time. So that may be one of the reasons. So that may be the reason for ignoring the base. So remember, if a number is written without base, that should be decimal number. So decimal number doesn't need any base, because that is the number system which is used everywhere by people. So since it is used everywhere, the base can be ignored. Even if you want, you can put it, that's not an issue, but there is no need, right? So this is decimal number system. Hope you understood them. The name is decimal number system. Here we have 0 to 9 digits. Total digits are 10. The base value should be equal to total digit, and then example. So the base is not must. So let's take the second one, binary number system. That is the name of the number system. So it also has digits, but here we have only 2 digits. 0, only 2 digits are permitted to use. So look at them, total digits. So you can easily count them. So how many digits are there? We have 2 digits. Look at the base. As I mentioned earlier, the base value should be equal to the total digits. So here also it's 2. So let me write one example. So 110. So you must be very careful here, because suppose if I write 110 without mentioning the base, definitely it must be pronounced as 110 and should be taken or should be considered as decimal number system, because we as we discussed just before, the numbers which do not have base should be taken as decimal number system. But look here, I have written this as binary, but forget to put the base. Definitely this is wrong. This will be treated as decimal. So if you want this as binary, put the base. Again, TWO, the words also possible. You can write the base in words or in number, 110 base. So hope you understood the importance of base for every number system, right? So look at the third number system. This is octal number system. As I always say, most of the ICT words have the meanings. So whenever one word is introduced, or whenever you see a word first time, try to guess the meaning without getting much explanation. Better take the word and guess something. So that may be the easiest way to study ICT, because most of the ICT words have the meaning. So even here, look at them, all of them have meaning. Octal. So all of you can understand the meaning of octal, right? So it's 8. So here, octal number system has 8 digits. So definitely they must start from 0. So 0, 1, 2, 3. It is up to 7. So 0 to 7 digits are used in octal number system. So how many digits are there? So you can easily count them. So we have 8 digits. As I told you earlier, base should be equal to total digits, so it must be 8. Here also I can write one example. So 730. Again, if I miss the base, if I forget to write 8 here, it must be 730 and it will be decimal number. So here also make sure that you have 8 here. 7 is a digit, 3 also is in the digit, 0 also digit. So 730 is a valid number in octal number. Finally, hexadecimal. Hexadecimal number system is something different than the previous 3. Look at them. In decimal and binary and octal, in all these 3, we use only numbers as digits, 0 to 9, 0, 1, 0, 7. And also you can find one pattern. Look at them. If it is decimal, the digits are before 10. Decimal means it's 10. So before 10, so 0 to 9. So here it's binary. So the binary means 2. So look at them before 2. So from 0 to 1. Octal 8. So the digits must be before 8, which means 0 to 7. So if you take the same, if you follow the same pattern, you can take this range 0, because hexadecimal means 60, right? The meaning of hexadecimal is 60. So definitely it must be 0 to 15. Have you understood? So it must be 0 to 15 because hexadecimal is 16. So to take the digits, you cannot put the 16 here, so it is 0 to 15. But the problem is, but the difference is here, we don't use numbers for whole range. Here 0 to 7, all of them are numbers. Here all of them numbers. Here also numbers. But here, we divide this range into 2 halves. The first half would be numbers 0 to 9. Right? So 0 to 9 can be numbers. The rest of the data, which means 10, 11, 12, 13, 14 and 15. For them, we use alphabets. So for 10, it would be A. So 10 is represented by A, 11 is represented by B, 12 is represented by C, 13 is represented by D, 14 E, and 15 it would be F. So for 10 and 11 up to 15, we don't use the numbers directly. Instead of using numbers, we use alphabets. So I can say the digits used in hexadecimal would be 0 to 9, comma, A to F. But remember, A is 10, B is 11, then finally F is 15. Right? So we will get some more knowledge and more stuff when we go through. This I hope this explanation or this introduction is more than enough at the moment. Total digits, it's very simple, 0 to 15, so definitely it is 60. Base value should be equal to this one, it is also 60. Here also, next one example. For example also, I can write in different forms. Even, look at them, 1, 5, base 60. It is a number, it is a valid number in hexadecimal because 1 is here in the range, look at them, 5 also in the range. So, someone can write 1, 5 as a valid number. Even this is also right, A, B, base 60. If you want to write 10, 11, 10 cannot be written directly. So, instead of mentioning 10, we put the letter which represents 10, that is A. Instead of writing 11, we put the letter which represents 11, that is B. So A, B, base 16, that is also correct. Even this is also correct. A, 9, base 16. Right? A, 9, base 16. A is 10, so I can put A. Then 9, that is in the range, so A 9 base 16. Here all of them are numbers, here all of them are letters, here both of them are mixed. So we can have three different numbers in hexadecimal number system. Right, so these are the 4 different number systems: decimal, binary, octal and hexadecimal, and their basic characteristics, right? Their digits used, the total digits and the base value, and some example. I might explain one thing at the beginning. Actually, I have forgotten to explain. That would be important. Some of you have idea, but it is important to understand that. So better to mention that also. So for an example, look, I take one number here, 150. It may be any number, but I take 150. Look here, this 150 is the number. Because in mathematics we have two names, number, digit. So 150 is called or must be called number. In this number you have 150. 1 should be a digit in 150. 5 also one of the digits. 0 also one of the digits. So 150 is a number, but every character which we write there should be called as digits. It is digit. Not only 0, 5 also digit, 1 also digit. So, but 150 should be a number. This is not only for decimal number, this can be applied for all the numbers. Even 110 is a number. Doesn't matter it's decimal or binary or hexadecimal or octal. 110. This one is a digit, this one is a digit, this is a digit. So the fact is very short. If you use 0, I'm talking about decimal. If you use 0 to 9 in a number, all these particular characters are called digits. But the one which you have formed should be called a number. Right? So this is the introduction for all these 4 number systems. So hope you have understood the various number systems used and their characteristics and some examples. Hereafter, we have to start an important part, that is conversion. So look here, 150 is in decimal number. This 150 should have a similar value in binary. This 150 should have a similar value in octet or hexadecimal. So we should be able to convert this 150 into binary, into octal, into hexadecimal. At the same time, we should be able to convert the other numbers to other number systems. So it takes some time to, take all these conversions. So we can start them. We can start those conversions. In fact, we have around 10 conversions. So we can start them in the coming tutorial or coming class. So before that, you have to watch it again and understand the fact, right? So that's it for today. We can start the class in the next maybe week. Thank you for watching.